So this lesson's all about direct variation. It's really simple. I know there's some terms in here that may look a little funky, might make you think otherwise, but just make sure you stay with it on this one. It isn't too bad. So first thing, direct variation is two quantities, x and y. So there's going to be an x-intercept and a y-intercept, or multiples. We're using both axes, and we're trying to set up the equation y equals kx. Okay, this is the key here. If something is in this form, it is considered a direct variation. I'll kind of explain what that means a little bit more. K can be any number except for 0. Okay, any number except for 0. A number k has a special name. It's called a constant of proportionality. Okay. Looking at this graph, some things I want you to note is the first thing, the point, if a point is to be considered a direct variation, it must start, or at least go through, the origin, okay, point 0, 0. If it doesn't, if it comes over here or over here and misses the origin, point 0, 0, it is not considered a direct variation. So that is a very, very critical point. Other big point with direct variation is normally they, at this point, we're saying they both increase. So as you increase with x, the y will also be increasing. So notice as we move farther to the right that the y values are also increasing. So you should have a line that's going up to the right. Okay, so let's look at some examples on how they're going to be applied. Example 1. Let's look at two tables here. So tell whether x and y show direct variations. Look at these graphs. Notice that they're increasing up by 1, by 1, by 1. Over here, it's increasing by 2, by 2, by 2. So let's go ahead and just graph the points first. Okay, so on this graph, you notice we have point 1, negative 2. We do have 0.20, 0.32, and 0.44. So you'll notice that they are increasing, which is what we want for direct variation. They are increasing to the right. And the problem, though, is they do not go through the origin. Therefore, it is not considered direct variation. Okay, so it is not. Over here, letter B, you can see we have 0.00, which that's a good sign right there. It goes up 2, 2, 4, 4. So we have it's pretty constant. Plot the points visually, helps you see it. Notice it does go through 0, 0, and it is going up towards the right on a straight line. Therefore, we know it is direct variation. Okay. The next one. Another example here, example 2. Okay, looking at the graph piece of it, or I'm sorry, the equation piece. Tell whether x and y show direct variation. So we're trying to get that special y equals kx. So if you'll notice here, we have y plus a number equals 2x. We have to get rid of this plus 1, and we can get rid of plus 1 by subtracting 1 from both sides. Okay, so we end up now having y equals 2x minus 1. Well, we do have it looks like y equals kx, the k being 2 right now, but the problem lies right here, this minus 1. We do not want anything out here in this constant area. Okay, so because there's a negative 1 out here, this is not considered direct variation because we'll be messing with our y-axis, and if you were to go and graph this, it would not go through the origin. Okay, so this equation cannot be written as y equals kx, so x and y do not show direct variation. Over here, we have 1/2 y equals x. We almost have the y by itself over here. We can get rid of this by either dividing or multiplying by its reciprocal. We'll go ahead and multiply both sides by 2. So 1/2 times 2 cancels those out. So we have y equals 2x. Notice that the 2 is the k, x is x, y equals kx. We are in that form. Therefore, we can say this is direct variation. All right. And make sure that's it. I think that, oh, we have one more I want to look at. Okay, looking at tables. The table shows the area in square feet that a robotic vacuum cleans in X minutes. Okay, so you have X at 1/2, you have 8, 1, 16, and so on. Graph the data, tell whether the X and Y. So that's first thing, let's graph it. Okay, so we graph the points here. Notice it goes through 0.00. Okay, and now we increase at that rate. Okay, this involves slope a little bit. No, we did a lesson on slope 2 days before. This does have a constant slope. Write an equation. Okay, write an equation. Well, because it goes through 0.00, this will be in the format of y equals kx. Okay, well, we need to do the slope. Slope is rise over run. So we need to go up 8 over 1/2. Up 8 over 1/2. up 8, 1 over half. So slope form is y over x. What's the change in y? Technically, it's going to be 16 over 1 because 8 divided by 1 half is 16, so 16 over 1. So y equals 16x is what we're going to be trying to do here. Okay, either the slope, change in y, or change in x. Then it says use the equation to find the area clean in 10 minutes. So that's our x. So if we were to plug in 10 for x, we can find out that the area in square feet will be 160 feet squared. Okay. Hopefully that helps, and look forward to answering any questions in class.